pressure. When you hear that song by Queen and David Bowie, it's kind of sad. It's talking about people being under pressure, having a really hard time with life. Well, when I'm talking about under pressure, it's a little bit more cheerful. We're talking about using gemstones and putting materials under pressure for science. And I think that's a pretty interesting concept. What I'm specifically talking about are diamond anvil cells. We use diamond anvil cells to test materials under gigapascals of pressure. The gemstones we like to use are, for example, diamonds, rubies, mosenites, and cubic zirconians. In the picture, you can see a Type 1A Bowler Almax design, which is what we're designing our diamonds to be used for testing. To do this, though, we need to cut these diamonds. Currently, you're only able to purchase these diamonds through a store, and they sell for about $2 grand a piece. And we want to try to cut costs down on getting these diamonds. In the picture, you can see a lathe. This is the lathe we intend to use to cut these diamonds on. We're going to start by cutting cubic zirconians and working our way to diamonds. For most of the cutting, we can use regular steel A2 steel tool bits to cut them until we get to the diamonds, in which we'll have to use diamond tip bits to cut them. Now, these diamonds will be set in anvils. And if you can look in the picture on the right, you can see that the anvil has a slight angle that matches the diamond. That is intended to help increase pressure that we can put these diamonds under. The steel used in these anvils will be A2 tool steel that has been hardened. This will allow it to increase the pressure instead of having straight edges and just pushing it straight down. The top left picture is an example of the anvils that we use in the lab currently. Now, once we have everything cut and we have this tool steel done, we plan on compressing these diamonds. In the picture on the right, you can see a hydraulic press on top in the top anvil pushing down through that jig that allows you to put pressure on the bottom diamond and the material that is in between them. Our goal is to pressurize this material to 30 gigapascals. We want to put as much pressure as we can, but we also don't want to shatter these gemstones. And the picture above is a good example of how the anvils are set up. In picture A, you can see the top piston and the bottom piston, and how the top piston will fit into the sleeve of the bottom piston. That way you can put maximum amount of pressure downward on the diamonds versus getting left and right pressure on them. You can also see how the diamonds are seated in the anvil and how they're held in place by an epoxy. And you can see where there's a gasket in the middle. But if you go to picture B, you get a better view of that gasket and the points of both diamonds. The gasket will keep that sample chamber sealed up, and in that sample chamber, you'll put whatever you want to test, as well as ruby under there, so you have a constant variable, so you know you can compare your results of the sample versus something constant. And then in picture C, you kind of get an idea on where the pressure is coming from. It's coming from every angle on those samples in the sample chamber. So in conclusion, while it's not, as I said, it's not depressing like David Bowie and Queen's song Under Pressure. It's a lot more exciting. It's a lot more fun. We want to cut these diamonds to put material under pressure up to 30 gigapascals and try not to break anything. For example, in the left picture, you can see an example of a broken gemstone because it had too much pressure. In the right on the top, you can see and bottom, you can see the setup in the lab where we are running lasers into it and we're using microscopes to observe the material under pressure. All in all, I feel this is very interesting and a fun topic, and I was glad I would be able to help out a little bit. Thank you very much.